Hi everybody. In this lesson I want to talk about the slope-intercept form of a line. And so you remember that the slope is a measure of the steepness and the direction of the line. And if you know another thing about slope you may remember is if you have two ordered pairs on a line, you can then compute the slope with the formula that the slope is the rise over the run. Remember, rise means, rise up and down, so you should think y, so it's the difference of y's that go on the top, and the run is a horizontal, that's the x-axis, so the x's go on the bottom. Okay, so here's an example of a line, and I have some points indicated on here. And so, for example, there's the ordered pair 0, 1, and this would be the ordered pair, let's see, 2, 2. And this would be the order, let's see, 1, 2, 3, 4, and up 3. And this is going to be 6, 4. Okay, so I have these forward pairs, and and the thing I want to illustrate here is it doesn't matter which two ordered pairs you choose. If you were to choose, this point 0, 1 and this point 2, 2, and then apply this slope formula, your slope that we denote by the letter m would be the difference of the y. So I can take this y minus this y, that would be 2 minus 1. And then if since I started with this y, I also want to start with this x, 2 minus 0. And so notice that gives me 1/2 for that slope. And it won't matter which of these 2 points I choose. If I'd have chosen say this point right here, which is 2, 2, and this other point 6, 4, then your slope m would be your difference of your y, so I get 4 minus 2 over your difference of the x's, 6 minus 2. And so you'll notice that gives me 2 on the top and 4 on the bottom, but that's still 1/2. Okay? Or just one more, if I was to choose, how about this one right here and this one right here, 0, 1 and 4, 3. So my slope there, and it doesn't really matter which one you choose to be your x1, y1, and your x2, y2. I could have taken this y minus this y, 1 minus 3. But then I'd have to divide by this x minus this x, 0 minus 4. So I get negative 2 on the top and negative 4 on the bottom. The negatives cancel, and I still end up with 1/2. Okay? So in this case, you can certainly see from choosing some points that the slope is 1/2. You can also see that from the rise over the run. When I go from this point, say to this point, I go a rise of 1 and a run of 2. So 1 over 2. Or if I go a rise of, I could go a rise of 2 and a run of 4. Okay, so either way, your slope's 1/2 there, and you can also tell that the y-intercept here is 1. And so since the equation of a line, the slope-intercept form is y equals mx plus b, if you can look at a line and you can determine its slope from the graph and its y-intercept, then you can just plug it in and say, okay, I know the equation of this line is y equals, in this case, 1/2 x plus 1. And that should satisfy every single one of those points. So like, for example, if x is 6 and y is 4, notice that that's going to work here, isn't it? 1/2 of 6 is 3. 3 plus 1 does give you a y value of 4. So that point, that ordered pair, satisfies that equation. 4, 3 would also work. 1/2 of 4 is 2. 2 plus 1 is the y value of 3. Okay, so if a line is written in this what we call the slope-intercept form, we call it slope-intercept because you can just look at the equation and say, hey, there's my slope and here's my y-intercept. Then it's very easy to graph. So for example, if I wanted to sketch the graph of the line f of x equals 3x minus 5, remember f of x is just a fancy way of saying y. y equals 3x minus 5. I know my y-intercept is negative 5, and my slope is 3. And I can think of that 3 as a rise of 3 over a run of 1, or a rise of negative 3 over a run of negative 1. All those are the same thing. So here's my y-intercept down here at negative 5. So that's where it crosses the y-axis, and then to get another point on the graph, all I have to do is go a slope of 3. So that's a rise of 3, that'd be up 3 and a run of 1. Rise of 3, run of 1. Rise of 3, run of 1. And so that's going to be the graph. If I connect those dots, that'll be the graph of this equation. I could also, suppose I knew this point, notice I could go a rise of negative 3 and a run of negative 1. Rise of negative 3, run of negative 1. All right, so that's going to be my graph of that line. And just to check and make sure, notice that this looks like that's the point 2, 1. So 2, 1 should make it true, and it does, right? 3 times 2 is 6. 6 minus 5 is the y value of 1. And every single ordered pair on that line will make that equation true. Okay, notice here's another equation of a line, 5x plus 4y equals 8. But this is written in a different form. When we have both the x's and y's and on one side no fractions, we call that the standard form, or the general form of a line. And so if I want to very quickly and easily graph that line, I can just simply rewrite it in the quick and easy to graph slope-intercept form. So the slope-intercept form, I just want to solve for y. So I'll go ahead and subtract 5x from both sides. And then I'll divide both sides by 4 to get y by itself. So I get that y is a negative 5/4 x. Remember, this 4 divides each of these terms, plus 2. So then I know that my y-intercept is 2, and I know that my slope is negative 5/4. So to graph this, I'll put a dot at 2 on the y-axis. That's my y-intercept. And then to find another point, I'll just go the slope of negative 5/4. That'll be a rise of negative 5 and a run of 4. Okay, so rise of negative 5 and a run of 4. Notice I could also think of it as a rise of positive 5 and a run of negative 4. So if I went up 5, this would be 3. I'm going to be off my graph there, and then back over here 4. You see that that's going to line up, isn't it? So let's go ahead and connect those dots, and that would be my graph of this line. Okay?